start up the simplest one. Most people who are in computer science or MIS, you should at least be familiar with pipes, right? Now, if you pick any program that is shell-based, right, such as dir, all these are programs. What other program do we have in the Windows prompt? I know there are commands, but for most of the commands, like copy. So that means if you do copy.exe, oh, why can't I? Okay, it depends on how it's implemented. Okay, let me do CLS. Right. Now, for some of the prompts, some of the things you type here may be programs. So, for example, if you type something like Java, that means that there is probably someone called java.exe who will respond. So Windows does have this behavior where if you type anything, let me move this down a bit. So typing Java will be the same as typing, just a sec please. So course evaluations are ongoing, and so that means that for some of the calls, when we get them from the pros, we have to answer so that people can answer and do course evaluations effectively. Okay, so what we said was you can do something like java.exe, right? But one of the things, so I'm going to switch to Linux just shortly, just to illustrate, or should I just? Yeah, all Windows. But Windows has, okay, I'll try and see if I can do something interesting. Okay, so one of the things you can do, so for example, if I do dir lists what is in a folder, right? So one of the things I can do is I can say if I dir, I can pipe. So this is pipe. So pipe means when you type one thing, you do bar. That means it's going to send the output from one program to another. So it's going to send the output from what? dir to less. So now what less does, so less, you see that, okay, this is, oh, let me quit. Let me pick a place where maybe there's more data so that maybe you appreciate this a bit more. So let's go to the Windows folder. Right. So this is the Windows folder. There's a lot of stuff coming out. Right. So when I do dir, that's what I get. It just tries to get everything. Right. Now, in addition to doing dir, you can actually, as I said, using the pipe, you can actually chain 2 or 3 things. That's tell one program to send output to another program without having to do copy paste or anything. So the way you usually do it is dir bar, that means pipe, and then you can do less. So less is another program that actually holds some input and will not let all of it come at once. It will let it flow to a point. So that means that the normal behavior of dir is I want to just send everything. And less is a different program. He supports doing up and down so that you can actually take your time and appreciate the data. Right. So that means that one program is sending what? Output to another program so that that program can work on it. Right. Now in programming 1, okay, question? The bar. Mm-hmm. the output from dir to less, to another program. That means less is a program, dir is another program. And so to say dir bar less, it means that what? I'm sending the output from this program to the other program. Right. Let me do, okay, so I'll make this one a very simple one. I'm just going to do a small Visual Studio code, just to show you. I know when most people are doing programming 1 or programming 2, they don't think about piping. But I'll show you one way that when we were in school, we used to test our programs, right? And the way we would do it is, we will be able to pipe the output of one thing into another, right? So that when something is running, so what some people do when they actually start typing all the commands, because some programs you have to type in commands, right? Where say you enter first name, then you type, enter middle name, you type, enter last name. What you can actually do is you can tell one program to pipe to another program. So that means you can tell one program to create some output, another program to do some reading. Right? So I know people have not done C#, but it looks a lot like Java. So we'll try and I'll just do very simple examples. Right? Like something that maybe prints numbers, something that prints numbers in a loop, and somebody that would take it and try and say what's the length of it. So we'll do a very small program. Come on, be good. Okay, let me just see how fast this is running so far. If it's slow, I have to speed it up a bit. Okay, so it's on power saver. Let's go with high performance so that we can at least enjoy some speed. Okay, so we are using C#, and I'm picking console application. So I'm going to create a program called PDC, that's this class, output. Right. So this will just be a simple program that will just do a simple loop and be outputting it. Okay, so it's creating. Okay, I know people have not done C#, but you should not be afraid of the other languages. Actually, they look very much like Java. There's not too much difference. The syntax, as you can see, this one also has a main, right? And so what this program will do is, I said I wanted it to actually print some numbers for me. So I'm going to first of all say my int 0, and for int I, oh actually, sorry. I actually don't need to do, I can just do int I equals, okay? I can keep all, not int 0, I have to say I equals to 0, I less than 100, I plus plus. Right. And what I'll do, oh, come on. You've seen this loop before, right? This is the same thing you have in Java. So you can actually transition very easily. And instead of system.out.println, in Java you have system.out.println. In C#, you don't have to learn this. I'm sure that you can pick it up at a different time. Console dot write line. So what he'll do is he'll be writing the different numbers. So when I run this, all he'll do is he'll just output the numbers. Right? So this is a very simple program. Java or not, people understand what it's doing. It's a loop and it's outputting things. Right. So let me, if I run this, let's see. It'll be very quick, I'm sure. Okay, it's output and then it stopped. So it was just supposed to output a bunch of data, right? So what I'll do is I'll go to where this project has been created and get the compiled file, the compiled program, just to show you what's going on. Okay, so in documents, it should be Visual Studio, shouldn't there? Okay, there's Visual Studio. It's projects, and this was called PDC output. Okay, so there is my program, right? So I'm going to copy this out. So the program has an exe. There are a few other things that go along with it to help it run. But similar to what you have for Java. In Java, when you finish compiling, you have a jar or a .class file, right? So here I have a PDC. So someone actually showed me this. You can just type cmd and then you get a command prompt. That's also another good way. Okay. So that means that if I do dir says list all the things there. There's a program called what? PDC output. That's the one we just created. So I can do PDC output and hit enter, and it runs. So this is the normal behavior of P. Is running the EX, because remember it's supposed to count to 100, so it counts. So I'm just showing you that it actually counts. And so I'm going to do the pipe again, just so you can see. So pipe to less was the program, and so that means now I don't have to have any sort of grade skills, having to write another program and another program. What you can do is you can have pieces of programs, and you can tell one program, send your output towards the other program, and another program can use it. Right. So this is this program running. Now what I said I'll show you was a way you can automate some of your testing. So I've written one program. I'm going to make another program that actually reads, would read some input and then do something with it. Right. And I'll let one program pipe to another, just so you understand how this piping works. To limit the output. Pipe. Two lines at a time. So what pipe was supposed to do, what pipe was initially designed for was, what they realized was people who were using computers, sometimes you are using a program and it just spits out a lot at you and you don't know what to do. So what Les does is he would keep scrolling the output until he fills the screen. So for example, dir by himself will just give me everything in Windows. That's quite a lot. So instead what I'll say is dir pipe into less. So the moment he does it, he stops, waits for me. And then I can do my down, 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 or up, up, up. And you can see I can even go up and down. While the initial program, I couldn't go up and down. With your arrow. Arrows. The arrow down, yeah. Because normally, in a command prompt, you don't have those options when the data is just coming. It just spits it at you. But when you say less, then that means that, so that's another program. What he does is you take the input, and then you hold on to it, so you can have time to read. Right? So that's an example. Now, what I said was I'm going to write another program. So PDC, one was called output. I'll call this PDC input. And what this one will do is he will read. Let me see if I can do that. No, console dot. This reminds me all the good times. Okay, so like programming one. Right, console or read line is supposed to what? Just read something from the user, right? And it's going to get a string. So what I'll do is I'll define a string my input. And when I do console.read line, I'm going to put it into this one, right? And I'll say while not done, I'll define done as a boolean. Boolean done equals false. So when it's false, we'll go in there, and what we usually teach people is to have some way to terminate the program. Of course, it's good practice to tell someone what to type to make the program stop. So I'll just do that. Console.out the right line. Enter. What should we say should stop? Okay, enter 99 to stop. I know it's a number that will be encountered in the other one. I can even make it enter 50. So when it gets to 50, so I'll just make it stop at 50. So I'll say if my input dot compared to, better make sure this would, okay, compared to string. So compared to 50 is equal to 0. That means that it's the same. It's similar to what you have in Java. Then I'll say console.out.writeLine, you are stopping. And then I'll say done equals true. Once done is equal to true, it will hit the while loop and I'll break out. Else, what I'll do is else I'll enter console.out.writeLine. You entered. It's just an infinite loop. So long as you are system.out.writeLine. So long as you are entering data. So what he has is a simple program that says read data from the user. The while loop is going to go on infinitely because it's based on a done. So if that variable is not set, you keep going. If he gets to true, then this program will stop, right? So what he's doing is he's going to read input from the user, check to see did you enter 50, and if you entered 50, I stop. If not, I say, oh, console.out, what did I, oh, okay. So what it compare does, same for the way it works in Java. So it'll compare two things. I say is A less than B. If they are the same, comparing, so it's like subtracting the code. So everything has a representation. So if say compare to, so if it's less than, it will be negative. If it's greater than, it will be positive. So that's comparing two things. Right. So I'll run this program. So we see this program running standalone. Okay, so enter 50 to stop. So I can enter some stuff you entered, and I can keep going, enter, keep going, enter. But if I do 50, I stop. So that means I've written one program that what outputs a bunch of numbers, and another program that wants to what keep reading numbers and just outputting them. Right. And it's similar to what I did last time. I'm going to find where that program went to. So let's go to Documents. Where's Visual Studio? This projects. There is PDC. Oh, that was PDC input. And please, this works the same way for Java. Java, you can do scan from the input. So that means you can have two Java programs that do the same. Right? So in Java, I think you can do a buffer reader and scan from the input. So when someone types, so everything that C# is doing, Java 2 can do. That is printing to screen. You can do the same system.out. Print line, not write line. It's like they all just sat down and said, I want to make mine look different. So it looks similar, but different enough. Okay, so back to the temp folder. And within here now, I have another program which is called PDC input. Right. So what I'll do is, I'll let one program pipe to another program. So there was PDC output, and there's also PDC input. Right. And this is the guy who wants to get some number or get something. Until he sees 50, he's not stopping. So the piping I was talking about, so for people who have not thought of it, I'll say pipe, the guy is saying output. That means he's going to take what he has, send it to PDC input. Right. So that means that what's coming out from this program is being sent to what? The other program. So as he's spitting out. So this is what piping is. And so you can see that he went through, and then he just repeated what the guy was doing, that you entered, until he got to, sorry, I think he got to us. Okay, so what can I do to make this a little bit easier to read? Less, pipe to less. So actually you can keep piping 2, 3, 4. You can pipe as many things as you want. Right, so long as one program can take, sorry, CLS, clear screen. So long as one program can take, you can also do, right, so that means that this program gets something piped. That means so long as the console comes out, he's going to take it and send it to the next program. So long as you plan your code that way, where one person takes something, is outputting, another person is reading, another person. So we used to do this when we were doing a lot of tests, because sometimes you didn't want to sit there all night. So what we did was we have like files containing the input, and then when we click, we'll leave the room and it'll run. You'll not be there. So you're like, oh, you're working, while you're standing outside chatting, and then when you come back, right? So now it's piping, and so that means that it slowed it down, and then I can see what it's doing up until it goes, and I can still go up. And so that is less. So that means that with pipe, you can send data from one thing to another, especially with command line. So is everyone okay with this one? So this is like the very beginning of communication, right? So when programs were being developed, they used to be console, and that means pipes were very important, because someone writes a program that outputs something, and then someone writes another program that outputs it. And if you take Linux especially, Linux has, so I won't switch entirely to Linux, but I will show you, okay, Windows, those who have Windows 10, you can actually install a Windows shell, the bash. So if you type bash, you can actually have this. So this is like an Ubuntu or Linux core. Cygwin 2 can do that. But what I liked about this was you didn't have to mess with the installation. After you went there and said, I've forgotten how to enable, but just search for Ubuntu for Windows or Linux for Windows, Bash for Windows, and you'd actually get all of the Linux commands. And if you go through Linux, a lot of their things, so there's a program, for example, called WC, which stands for word count, right? And that program is very nice, for example, because if you had a file, so I'll do less, maybe input.txt. So this file has what? 1, 2, has 4 lines of code. And I wanted to count what is in there. I can do something like, so cut is another program. So I just show you. Cut just means output something, like take whatever it is and spit it out. It's not like less. So cut is saying, if go and pick a file and just spit out whatever is in there. So if I say, so in here you can see something like, let's see, hi.txt. I can say cut hi.txt. So it opened hi and spit it out. Right. So that means I can combine cut and tell him to do word count. Right. But of course, I've forgotten what all the columns mean. I think, okay, I'll do -L. I remember -L means lines of code because I've been using this a lot. Because sometimes you have, let's say, people type their names in an attendance file, and you don't want to count. It may be thousands or millions. Or maybe you wrote a program that is logging errors, and you want to know how many errors happened. You want to open and count. So in Linux, the idea was to write tiny, little programs. And a lot of them are actually, let me see if I can find where it is. Is it user bin? Okay, so it's in user bin, and I did less. I want to get to, okay. So this is a lot of programs in there. If I want to slow it down, I'll say what? Into less, pipe into less. And I can see all of this, 7-zip, apt get, aptitude, at base 64. So there's so many programs. But the design thinking for Linux was write little programs so that when you take one, you pipe to another. So some people are very good at, so if you ask them to do something, they'll just combine little programs in Linux. Or write a very small program that has a specific task. So they don't have to write a program that's very large doing everything. Right? So the piping idea encourages this modularity. Right? And this modularity is only possible because what? We are able to have communication between 2 or 3 processes or programs over here. All right. So what I'll do, so we are now moving on. So hopefully I've shown people what the power of pipe is. Right. So, right. Encourages modularity. Right. So very nice.